You're listening to the Drive Forward podcast. We're cruising through the latest in transportation to inspire a better tomorrow.
Welcome to the 11th episode of the Drive Forward podcast. I'm your host, Emily Jankowski. Today, we're chatting with Ann Schlenker, Argonne National Laboratory's Director for the Center for Transportation Research. All right, well, welcome to the podcast, Ann. Let's go ahead and dive on in. Why don't you start off by telling me a little bit about your role at Argonne National Laboratory's Center for Transportation Research?
Well, thanks, Emily, for having me today. It's a real pleasure to be with you. I lead the Center for Transportation Research at Argonne. I've been at the lab for about a little over 10 years now, but came from an industry background, previous in the automotive industry. And I have the privilege, really, of leading 100 engineers and scientists in transportation and mobility research.
Absolutely. Well, I know when it comes to autonomous cars, many of us are quick to adapt a believe it when I see it kind of ideology. But your efforts with the U.S. Department of Energy's EcoCAR Mobility Challenge has university students taking connected autonomous vehicle technology from concept to reality. Can you tell me a little bit about this competition, your role, as well as the university students' efforts?
So this is one of the efforts that I'm so pleased to lead for the Department of Energy in Argonne. It's termed the Advanced Vehicle Technology Competitions, and the current series that we have is the EcoCAR Mobility Challenge. And this is a 4-year program that has a legacy of over 30 years now of these competition series, whereby the DOE sponsors this work and Argonne has managed these competitions. And then we do a solicitation, a competitive bid process to define our headline sponsors. Currently, it's MathWorks and General Motors, very critical partners for us. So it's this private-public partnership that makes it work. And what we're trying to do is emulate the product development process that we find in the automotive industry. So if you stop and think about that, a 4-year process, not a 1-year competition, get in and out, 4 years, whereby just as we would build a vehicle, design and understand the marketplace, do some early designs and sketches, move into component selection, then get into iteration of those components and doing some mule and prototype testing, and ultimately over to refinement and innovations and new technologies into it. So this is the plethora that we want to give visibility to students. And it's not just advanced propulsion and battery electrification technologies that we're looking for in these vehicles. It's really about the connected and automated vehicle space also. I think currently we have about 40% of the program content is really in that new connectivity and automation research. We're currently in year 3, so we're going to wrap up the spring of 2022. And these students have really been nimble and flexible because, of course, their world has been rocked by COVID as well, and their flexibility needs to be commended. But once these students graduate through the program with their faculty advisors fully intact and the mentors and the opportunities they've had to interact with all the industry and the suppliers to the program, they really are ripe and ready for a career back into the automotive profession. And we're training and teaching not just engineers, it's communication specialists, it's business specialists that have the business acumen as well. So it's many disciplines that come through this program with high success.
That's fantastic. I like what you said about being ripe and ready. It sounds like this is a multidisciplinary approach, and it sounds like from other competitions I've heard of, this seems to be a really unique factor with these. And I think it's interesting to get civil engineering students working alongside maybe those business majors or marketing majors to really understand how something begins and ends and how they need to work together, right, in order to get everything complete. That's awesome. Well, I know when we talk about futuristic transportation, people are probably quick to recall Marty McFly's DeLorean time machine from Back to the Future. I know you recently co-chaired the U.S. Department of Energy's Systems and Modeling for Accelerated Research in Transportation, or SMART Mobility Consortium, which looks at technology that could pioneer us into the future of transportation. Can you tell me a little bit about this effort and how you get people excited about the future of our transportation system?
So I've always told people that I think I'm blessed to be in the transportation space and in the mobility space, and that is because we can all relate to it as citizens and members of society, that we interact, we have places to go, people to see, right? And so we all relate to mobility and transportation. But the definition of what does mobility mean has been vague. And so one of the first things that we undertook with DOE and the National Lab System was really to define what mobility meant. And we've said it's the quality of a network or a system to connect people to goods and services and employment for a high quality of life. So to paraphrase it, it's really about an access to opportunity. How I can reach good education, good job, leisure activities, food, healthcare, all these other things that are important to my quality of life. And then how I improve my access to those opportunities that I see, and how I can bring technology or services into it. So smart mobility had been underway with DOE for 3-4 years now. In fact, they just launched another series that will take us for research and development portfolio for another 3 years. We're very thankful for that, for the Department of Energy. And everything from, again, advanced technology that you can see and touch, things like connectivity between vehicles and the infrastructure. So to parse it down a little bit more, cars that stop at red lights and didn't know the light was going to turn red, so maybe I brake too fast. Conversely, maybe I'm stopped at a red light and there's no pedestrians that need to cross the street, or there is no cross traffic. So hence I'm wasting fuel as well. So how can I improve connectivity between vehicles and the infrastructure, the traffic signals, so I can have better traffic flow and ease congestion and give an asset back to the consumer or the driver, which is really their own time. So those are examples of some of the technologies. But again, you've heard me mention system focused, and I can't leave that, because that's one of the other things that's really important. And I'm going to give you a concrete example that we did through Smart Mobility that involves some field testing as well as some modeling work. And it was something called adaptive cruise control, and you might have it on your own vehicle, whereby the car, your own car, spaces itself out. It could brake, it could speed up to keep a constant speed. And you personally in your car net a 5 to 7% fuel economy benefit. Good news, right? We're saving fuel, you're saving money. However, that technology, because it's single vehicle focused, we found when we looked at our modeling tools, Polaris from Argonne as an example, really had a negative impact on traffic flow overall holistically between the cars and the trucks and the other lanes of the highway that did not have that technology as an example. You had phantom traffic jams. So we could have a loss of fuel economy overall in the system. Your individual vehicle benefited, but the system did not. Then we overlay connectivity, which means communication between the cars. They have situational awareness. Cars can talk to each other virtually, right? See each other. And then all of a sudden, the system has that opportunity for a 20% gain in fuel economy. It's huge. And that also means an improvement in congestion and traffic flow. So that's why it's so important to look at component, the individual vehicle itself, and then the system as a whole to make certain that there aren't unintended consequences as we deploy technologies out into the field. And I can't really be remiss without talking about technology and what I think has really shaped the way we interact. And I'm certain you'll agree, Emily, that smartphones have changed all of our lives. And the same is happening as we translate some of that technology over into transportation and mobility. That is real-time information and how that shapes my life, how it changes the way I interact. And you probably have experience just like I do, that maybe I leave for work when I was driving into the office at a different time because I've got an alert that there's a traffic jam or there's an accident or there's snow on the road, and so give it a time for the plows to come and clear. All of this real-time information influences the way I interact. And I think that data that we can now collect through Internet of Things and sensors and having reliable and robust trust in the information that we receive, and in the back office applying AI and machine learning and other tools to that data for predictive means also, and then making that information actionable. So I think that real-time information is another impact of technology that's really shaping the way we change our mobility habits.
Absolutely. I think for sure our smartphones definitely changed how we go about our day. And I know when we eventually integrate connected and autonomous vehicles, I feel like that might also change. That's a great way of comparing smart technology, right? And thinking about unintended consequences. But I also like what you said about the quality of access to opportunity. I think that's a really great point. And I hope our transportation students are listening, because that's a really great just synopsis of what transportation is. Fantastic. Well, speaking of futuristic technology, how do you see us going beyond vehicles and the future of goods delivery?
So the United States, as they built the highway system in the 50s and post World War II, there was an aspiration for suburban life, for open roadways and skies, and touring, and personal car ownership. That has been a foundation, really, of American society for the last 50 plus years. But I'm not certain it needs to be. As we look at challenges that are out there in transportation and mobility, and I want to give a shout out to the Department of Transportation this time, that they really ran a smart city challenge a few years ago now. And there was a common theme of challenges and issues that these cities and urban areas were facing. And it was applicable to rural as well. They were concerned about air quality. They were concerned about CO2 and safety, traffic flow or parking or curb management for goods delivery, last mile, first mile services to get to mass transit, an example. There's a commonality within that. And so that really is shaping and leading to solutions in technology. So specific to your question on goods movement, we're used to the package delivery to our front door, and e-commerce has boomed. And many of the companies right now will say in these COVID times, as an example, that e-commerce has really opened up for new customers with the need for package delivery, food delivery, et cetera, to point back to your house. But some of these companies are now evaluating, well, what else could I do differently? We do think that it is most fuel efficient for a high firm that has great logistics to simply add another stop of their 200 stops per truck per day now, if that fits into the urban region. But there's other solutions as well. There's package lockers that are cropping up now. And that's an opportunity, but the fuel economy savings depends on how you're going to pick up that package. Is it an incremental trip, or is it just a trip on your way home from other business that you're conducting? Are you going to walk to the locker? Are you going to ride your bike? There's things like a shared trunk, whereby there's a transportation network company out there, and they're picking up people, they're having services, but the trunk is empty. So is there the opportunity to also move into goods delivery space, particularly when the trip is deadheaded? In other words, they're looking to pick up the next passenger and ride, and have some vehicle miles traveled that are not into the business mode. There's robot delivery bots that you see out on some demonstrations for pilots on streets right now. another opportunity. And we've studied drone delivery through the Department of Energy as well for various sizes and technologies of drones and whether that has an application. Relative to your question about automated vehicles and services in the personal car, can we get beyond that? Well, there's a few trends that fit, but it does depend on geography. There's growth in population, certainly in the U.S., but there's an aging of the population also that we need to be respectful of. There's also underserved population, and you spoke of equity before, and so how we can have access for all comes into play. Can we get into a service mode and a subscription mode? And there's companies that are trying these business models as well to see what's going to stick and what's going to fit. So I think some of that's going to play into this. Will we get to a full shared and a full subscription model to buy miles, like I buy minutes or data on my cell phone? I don't think that one size fits all is going to work in the US, but there is new opportunity for these business models and technologies. You're seeing some air taxis as an example, right? Far out there, previous thoughts, will this ever really happen? We're seeing it globally in a couple of deployments and demonstrations. Does it fit in the US, in the urban areas? It could. So that's another one that's just on our radar and that we're taking a look at also.
Absolutely. I think you hit it right on the head where you said that we're not going to have a one size fits all kind of model. Just like we have so many different vehicles on our roads, we're also not going to be able to have that for our good delivery either. That's a great point. Well, just one last question for you, Ann. What legacy do you hope to leave at Argonne National Laboratory Center for Transportation Research?
So this one took me aback a little, Emily, but it made me reflect that I have been very fortunate to have a 40-year career in transportation and in mobility. And so I took pause, and some of the things that I'm most proud of is really on a few societal goals that pulled at my heartstrings and drove the work that I did. And so I have to start with air quality, because this dates all the way back to the early days of the Clean Air Act. And I can remember Los Angeles not being able to see the mountains, or Denver having brown cloud. And air quality was really not wonderful for a large, vast amount of the US population. So we charted a course for emission controls on vehicles, for evaporative controls on vehicles, for different fuel formulations for reformulated fuel, cleaner burning gasoline, taking lead out of gasoline, volatility controls, and then recognizing that this common theme here, system of systems, that the interaction between the vehicle and the fuel was critical. So air quality, we've had an improvement of over 99% of emissions from vehicles, and I'm really proud of that. And similarly, I would say on fuel economy of vehicles, more than doubling of fuel economy for energy savings from our vehicles. And I can't leave safety, because, again, I started with passive safety systems, airbags and seatbelts. Tremendous improvement in what we could do for fatalities and injuries from our roadways. And then it progressed into active safety systems. So if you stop and think about anti-lock braking or electronic stability protection, now you've got forward and backup cameras, you've got blind spot detection, you've got lane departure warnings, on and on and on. And all of those, at the time, individual sensors now can be fused together, integrated, and that has really shaped the pathway for automation. So those are the R&D areas that I speak of, that I think I probably made the most contribution to. But with my time at Argonne and having industry background and then moving into R&D and being very application focused, right? Engineering focused, not as much fundamental basic knowledge, but application focused. What does that mean then? It means ensuring that you have relevancy in your research, understanding the impact that is needed and making certain that it's aligned to needs. And then acting with a sense of urgency, all right? Not research for research's sake, but what solution or what challenge are you really trying to solve? And then one of my other learnings was really about talk less and listen more. That the voice of the customer, whether that be a city, whether that be a supplier, whether that be your neighbor across the street, sometimes they can't even articulate what their challenges for transportation or mobility is. But if you have the power of observation, sometimes that you can distill that yourself, and then it becomes a relevant and impactful solution that you can bring to the dialogue. So I think that's important too, is bridging that R&D world to application science.
Absolutely. Well, fantastic. Well, Ann, that's all I had for today. Please know that we so appreciate the work that you, the U.S. Department of Energy, and Argonne National Laboratory do to improve our transportation and our transportation system. And we so appreciate your willingness to join the podcast. And listeners, thanks for staying tuned in.
The Drive Forward podcast is the production of Illinois Center for Transportation, a research center of the University of Illinois at Urbana-Champaign. We invite you to subscribe to the Drive Forward podcast on iTunes, SoundCloud, or Spotify. And while you're there, feel free to like or rate us. Thanks for listening. And keep the conversation rolling by using #DriveForward.